All right, working some more on the controller, and you can see here I've got a NPN 3904 transistor hooked up to the negative line going into the OLED display, and then that's jumpered over here to the main negative bus here, and then just a 1K transistor going over to one of the pins of the microcontroller. And when it is asleep, it's only drawing 41 microamps, which I'll tell you about in a bit here. And then when it's awake, so it just woke up here, and then it's drawing about 7 milliamps. So the last time we were here, when it was asleep, it was drawing 78 microamps, 78 instead of 41. So that's interesting, right? And then when it was awake, everything was turned on in high powered mode, it was drawing 40 microamps. It's still only drawing 7. It draws 7 milliamps if it's in high contrast or if it's in low contrast. It doesn't matter. It still draws 7. So I think because the battery that I'm running this off of is still at about the same voltage, I think this is attributed to the programmer. Because I've noticed this issue with the programmer sometimes where it affects the power draw of the system. And I haven't isolated what it is exactly, but I've got my little adapter board on here where I can disconnect the VCC line from the programmer so that I can still reprogram the microcontroller but run it off of its own power source. So I've got that disconnected, but there is another line in here, there's a transmit and receive lines that seem to affect power draw sometimes. And I even, if I put this down, just a second, I even put on my little adapter here a second jumper that I can remove because this particular jumper, this particular line, seemed to affect the power draw sometimes. So yeah, I think it was this. I think this was causing a greater draw to happen, and now if I cycle the power, switch it off, and then switch it back on, and it's clean. It's always 41.5 microamps when it's asleep, and this one agrees with that when I set it up to do it, and it's always around 7.5 or 7. Milliamps when it's awake in high contrast or if it's in low contrast. So so that's awesome. I don't need to have two 1000 milliamp battery packs or one. I probably could just use a 500 milliamp pack. And since this isn't going to be just on all the time, it's going to be most of the time I'll be sleeping. I'd be able to probably run it with a 500 milliamp pack for half a year. So that's fantastic. So the other little issue with powering this display on and off, I'll see if I can get it to do it. If I click, it seemed like half the time when it woke up, the screen would, there we go, the screen would be garbled like this. So it didn't wake up cleanly. It didn't initialize properly. It seemed to happen only when I clicked, or when it did happen, half the time, it was the clicking action caused it to do that. Whereas if I rotate it to wake it up, it always woke up cleanly. It didn't have that issue. So when I'm rotating, I'm using an external interrupt to make this thing wake up. And when I'm clicking, I'm using a pin change interrupt to wake this up. And this led me down a deep and dark hole, and I spent 2 hours screwing around with trying to figure out what on earth could be causing this problem, and I thought it was about interrupts. And I tried everything, and after trying everything, I concluded it couldn't be the interrupts. It had to be something different. And so, the library, I started looking at the initialize method of the library, and it does have to do a lot of setup. This is I2C, and it has to, there's a delay in the initialization method of 100 milliseconds, and then it has to do a lot of individual sending of commands, and I'm not really familiar with I2C yet, so I don't know why we have to do so many things here, and I haven't read the data sheet of the OLED display. I'm just using this library right now. So bad on me because I don't understand what's happening here. But there's a lot of commands being sent. There's another long delay at the end. And then the send command, this is just a function down here that uses the wire library. And every single one of those up there has to do these things here. And there's even another delay in there that they threw in, a 10 millisecond delay for every one of these commands. So there's there's a lot of delays in here, and maybe this is not as clean as it should be. So just for the heck of it, I put the initialization in twice, and I can't believe it, but this solved the problem. Just running on it twice fixes the issue. It works 100% of the time. It will not break, and it's pretty silly solution, but it works. And I need to dig in and try to understand how I2C works a little bit better, and why it's being done like this with this OLED display. But for now, at least, running it twice works just fine. So that ate up 2 hours, and then, but on the plus side, I got a really low power draw now, which is really great. So all in all, it was a good day, and progress has been made.